Let's look at our notebooks. We will start with the bagging overfit. In this exercise, we will investigate the effect of bagging on overfitting. We will first try a simple decision tree, then we will see the effect of bagging. Let's first create our dataset. It looks like this. We have a continuous variable to predict, so we will use regressors. Here we have our decision tree. We will use a max depth of 8. Let's import the tree. Then we will fit on the dataset. Then we will have these data points to make the predictions. It will go from -2 to +2 here. Let's get the predictions. Then we will plot the results. We show the predictions with the orange color here. Our decision tree has a high fluctuation, as you can see here. That usually means that we are overfitting on the dataset. So let's see the bagging. With the bagging models, we will just bag 100 trees, and then we will take the average of them. We did not use this sklearn implementation here. What we did is instead we just bag 100 independent decision trees, then we take the average result of those. So we have a for loop for that. So we have 100 decision trees in total. So inside this for loop, we will resample our data. At first, we will just use the same size as our original data set. So we will consider this 1000 data points. Then in this case, this will give me the sample size of 1000 here. Then I will get my decision tree, then fit on this sample data. Then I will receive my predictions. Then I will take the average and I will keep adding those. At the end, I will plot these results. And it looks like this. We see that we were able to dampen this effect of fluctuation. Then we saw that we can further dampen this fluctuation if we just reduce our sample size. This time, instead of 1000, we consider 100 data points for each of these decision trees. So that comes into play here when we are resampling. So this time we will just have 100 data points here. And this time our decision trees, they will just fit on these 100 data points each time. And again, we will get these results by adding them up. Here's the result. As we have seen before, this is going to have a smoother result. And we were able to further dampen this effect of fluctuation. But this came with the cost of bias. This time we had to increase the bias. Let's see our second notebook. In our second notebook, we investigated the effect of adding more trees in our bagging model. And we considered two different sampling sizes. In the first one, we used the full size. In the second one, we just considered 1% of the original dataset size. We have the same dataset here. In our first bagging model, we used the full size of the original dataset size. So we had 1000 here. And we just increased the number of trees each time. It went from 1 to all the way to 10,000 here. The result that we see here tells us that it doesn't really change too much, even if we keep adding more and more decision trees. So we have a similar response each time. As we have experimented before, if we change the sampling size, we may see a different result here. So that's what happens. So if we change the sampling size to 1%, this time we even consider a less amount of data points here. So over here, you will see that we just use the 1% size. With that, what we see is that we see the effect of adding more and more decision trees this time. So when we keep adding more and more, we see that we also have some smoother responses every time.